Try this question yourself. When you've done it, then check the answers. Part A, to find the range, we sketch the function first. So here is the x-axis, y-axis, e to the power minus 3x is exponentially coming down. So we like this. And the asymptote parallel to the x-axis, and it goes through the point 0, 1. Now we can see from the sketch the range so the y is always more than 0. For part B, we're going to sketch inverse f and inverse g. So one method is you work out the functions. So we write the f function. So we write 2x minus 7, we put it equal to y, then make x the subject. So when you make x the subject, you will get x equal to half y plus 7 over 2. So what you can do now, wherever x is, you write f inverse. Wherever y is, you write x. Then 7 over 2, you can write 3.5. Then for g, we got e to the power minus 3x, we put it equal to y. Then we take the natural log both sides. Now L and E, when they're next to each other, we cancel each other out. So we have on the left minus 3x equal to ln y. Then we divide both sides by minus 3. So you get x equal to minus 1/3 ln y. Now wherever x is, you can write g inverse. Where y is, you're going to write x. So it's minus 1/3 ln x. Now you can sketch it from here. So we have the y-axis. This is our x-axis. When x is 0 here, y is 3.5. So this graph goes through this point 0, 3.5. If you put this equal to 0, that means y is 0, you will get x equal to minus 7, so which is here. So you got 2 points, then you join them. So this is f inverse. For g, the ln graph looks like this. Because you multiply minus 1/3, so the graph changes in the other direction. This point will stay the same, but then other point becomes like this. So asymptote parallel to the y-axis, and is going to go through this point, which is 1, 0. Part C, number of roots, then we put minus f, or f inverse equal to g inverse. So there's only one solution there, or one root, because there's only one intersection. This line always increasing, this curve is always decreasing, so they're never going to meet again. It's only one point they meet. Now D, we have to work out fg of minus half. So f is 2x minus 7, g is e to the power minus 3x. So here f and this function, wherever x is, we write minus 1 half, so that becomes e to the power 3 over 2. Then we got the f function, wherever x is, we write e to the power 3 over 2. Then from your calculator, you get the answer 1.96. Just explain a little bit more about the sketches. So if we have y equal to e to the power x, the sketch looks like this. Let's go through this point, which is 0, 1. What happens if y is equal to e to the power 3x? So this is stretch, and the x direction with a factor 1/3. So this point stays the same, but the graph comes like this. So that height there is achieved earlier. Now what happens if we go y equal to e to the power minus 3x? Because x is replaced by minus x, that means it's a reflection in the y-axis. So this point is still the same. The graph looks like this. So this has asymptote at y equal to 0, positive x-axis. If we need the inverse of this function, to sketch the inverse, first we draw the line y equal to x. Then this point is 0, 1. Then we get the point here, which is 1, 0. Asymptote. Here was y equal to 0, positive x-axis. This will be x equal to 0, positive y-axis. Then it's going to go through this point. So it's coming from there, and it goes down. So this is the reflection of this curve, like this. The other graph had f was 2x minus 7. So to sketch that, when x is 0, y is minus 7. When y is 0, x can be 3.5. Then it's a straight line. Then we put the line y equal to x. For the inverse, these coordinates going to swap. 3.50 then becomes here 0, 3.5, 0, 7 becomes here minus 7, 0. So there we curve. It's also going to go through this point here. It's a straight line graph. So going to point 0, 3.5 here, minus 7, 0 there. Then at this point, y equal to x, inverse f and f itself, they're all here.